Hi guys, I'm Kyle from period 3 class, and now I'm going to talk about 6.1, the exponential function and its inverse. First of all, we're going to look at the exponential function, which is y equals to b power of x. The characteristic of the exponential function has the domain of xer, as you guys can see here, which is also known as x belongs to all the real numbers. And also for the range it has the domain of yer, and y is greater than 0, which also means that y belongs to all the real numbers. So for now, the y-intercept is 1, which is also known as 0, 1. And the horizontal asymptote is y equals to 0. So it's gonna be like, let's say this is the graph. Okay, so here's the graph, and the horizontal horizontal asymptote will be in this line. So next, please look at the red box here as I just draw the red box here. As I said just now, the y equals to b power of x is exponential function. So to look for the log function, we have to switch the x with the exponent y in order to look for the log functions. Now let's take a look at the inverse function. It's actually very easy to find the inverse function. All we need to do is to change the position of x and y, and then from y to x. So now we know that y equals to b power of x is the exponential function, and also now we know this x equals to b power of y is log function. So basically, if we want to look for the inverse function, we just have to change x with y and then from y to x. So for now, let's take a look at the example below right here. So the exponential function is given, which is y equals to 2 power of x. So now we know the graph of the exponential function is right here. It's going upwards. And then in order to look for the inverse functions, which is also known as the log function, it's basically the inverse of over the y equals to x, which is the asymptote. So you get the inverse of log facing downwards. So this is all for 6.1 unit. Thank you. So I'm gonna continue from 6.2, logarithms. So basically, what is logarithms? Logarithms is a quantity representing the power to which fixed number the base must be raised to produce a given number. So before we go through everything, I'm gonna explain about the format, how log works, how logarithms work. So let's look at this one. So normally log, so this one is the log question. I mean for log question, the log, the base, which is a number, and then the answer from the equation is equals to the exponential form. Okay, so so let's look at the graph. I mean the table right here. So we're gonna start from the easy one, which is the same exponent. So let's look at the exponential form. Okay, let me clear this first. Okay, so exponential form. As you guys can see, 2 power of 3 is equals to 8, and then 3 power of 3 is equals to 27. So do you guys realize that all the exponent it's the same. So so now we know all the exponents in the exponential form is the same. So let's look at the logarithmic, the log form. Okay, so let's look at here, and then you guys can see like all the answers are 3 3 3 3. And then like let's go back to this. So now you guys can see like the log questions equals to the log base equals to the answer which is the exponent. The answer, okay, so sorry, let me clear this. Okay, so the answer right here is equals to the exponent right here. So basically we just replace, we take the base. Normally the base, like the base is always the same as the base of the exponential form. So in order to make it clear, you just, okay, so let me clear everything again. Okay, so always remember that in log form, the answer is always the power of exponential form in the exponential form. And then like in log form, the base is always the base of the exponential form. So, and also the answer, the 8 is always beside like the bigger number of, like the bigger number beside the base. Okay, so for now let's look at the different exponent, which is harder, but it's quite easy if you get used to it. So okay, now you guys know like all the exponents are different, and then okay, so let's look at the first one first. This one, and then like we know that the exponent is 4, the answer is 625. And then okay, so let's go. If we got the exponential form and then we want to look for the log form, we have to do this. So first of all, okay, so I write it here. So first we have to write log. It's always log first, so it's like log, and then the 5 is always the base of the exponential form, as I said just now. Okay, the 5 is the base, and then like the answer is beside the base. The greater number is the answer from the exponential form, so it's 625. And then this one is equal to 4, which is the exponent, as I said just now. Okay, the exponent from the exponential form. Okay, so let's do some example. Let's do some questions. Okay, so I'm gonna do the first one, and then you guys can maybe you guys can just watch it. So for now we have to rewrite each equation in log form. So now we know that this question is exponential form. It's exponential form, and then we have to look for the logarithmic form. So okay, let me clear this. Okay, so now we know that. Okay, so you guys can look at this to review. So now we know the answer, we know the base of the exponent, and also the exponent from the exponential form. So it's very easy. So you just put equal log. As I said just now, log is always the first. So you just you just write log first, and then we know that the base of the exponential form is 2. So we just put it here. So it's so it's 2, the base is 2, and then we know the answer is 16. 16 is the exponent, so that's our answer. Okay, so look at question B. We know that the answer is 81. we know that the base of the exponential form is 9, and then the exponent is 2. So same rule, we put log first, and then we put the base of the exponential form, which is 9, and then after that we just take like the answer from the exponential form, which is 89, and then it's equal to the exponent, which we did here. That's all. It's pretty easy. Okay, so now we have to rewrite each equation in exponential form. Like just now we did is we write the equation in log form, but now is I give like two different questions. I like two example of exponential form. I mean like from log form to exponential form. So let's start from the question A. So what you guys gonna do, like first is you write down, like you write y log, you just follow the question, log 81. Sorry, I think I have to write it smaller. Okay, y equals to log, just follow log 3, the base is 3, and then the answer is 81. Okay, so what you're gonna do next is you move the log, move it to the front, so it's gonna be like 3. So log 3, if you move it to the front, it's gonna be it's gonna switch, like it's gonna be like that, like okay, 3, this one is the base, and then this one is the y is the exponent. The y is the exponent. So you just put it there, 81. So what you're gonna do next is you have to simplify this. What you're gonna do is, so this one we know that it's 3 and then power of y, and then it's 4. It's like 3 times 3 times 3 is like 4 times 3 times, in order to get 81. Okay, so give me a moment. Okay, so after that what you're gonna do is you put y. So now we have to look for the exponential form, which is y equals to something. So you move so now the value is the same, so we just cut it. So it's gonna be y equals to 4. So that's the answer. So now let's take a look at question B. So log, it's the same, you just put y we write the question, log 4256, and then like after that you're gonna put like log 4, and then the 256 you can simplify, you can make it smaller, which is equal to 4. We put the power bracket, and then it's power of 4. So we know that 4 multiplied 4 times, it's equal to 256. So you just put so you just put, okay, so now we know that it's
Good morning, everyone. I'm Chankahao from Period 3 Advanced Function class. Now, I'm going to talk about Chapter 6.3, Transformations of Logarithmic Functions. Now, as you can see from the function above, positive, negative is the reflection in the x-axis, and A is the vertical stretch or compress. Now, positive and negative after the log is the reflection in the y-axis horizontally, and K is the horizontal stretch or compress. Alright? and C is the vertical shift up or down. Now, I'm going to explain about the tiny example I show you below the function. Now, the example is y equals to 5 log bracket x plus 3. A graph of this function can be obtained by applying a vertical stretch and a horizontal translation to the graph of y equals to log x. Now, considering the y equals to log x is the anchor. Now, we need to transform it to y equals to 5 log x, which is stretched vertically by a factor of 5. Now, first, 1, 0 will be remaining as 1 and 0. Now, as you can see, the point is 10 on the x and 1 as the y, for y equals to log x. And then we shift vertically by a factor of 5. So it will be 10 to 1 to 10 to 5. Now, the asymptote will remain at x equals to 0 at this stage. Now, apply the horizontal shift from y equals to 5 log x to y equals to 5 log bracket x plus 3. Now, the anchor points and vertical asymptote will both shift 3 units to the left. Now, when you shift to the left, the anchor point will be shift from 1 to negative 2. And then the 10, 5 will shift to 7 and 5. As well as the vertical asymptote will shift 3 units to the left, which will be 0 to negative 3. Now, this is the rough sketch for the example y equals to 5 log bracket x plus 3. Now, we move on to example 2, which is a harder question, and we have to solve it algebraically. Now, the function will be y equals to 2 log bracket 3 bracket x minus 4 close bracket plus 6. Now, to find the x-intercept, we have to let y equals to 0. Now, 0 equals to 2 log bracket 3 bracket x minus 4 bracket close bracket plus 6. Now, and then we shift to the negative 6, positive 6 over, it will be negative 6. Now, using the log of a power, we can shift the 2 to square. After squaring, we have to use the equivalence law, which is the log base 10, it will move to the other side, which will be 10 to the power of negative 6 equals to bracket 3 bracket x minus 4 close bracket square. After that, we can use square root both sides to cancel out the square on the right side. And then the left side will be square root 10 to the power of negative 6. After doing that, we have to move the 3 over, which will be square root 10 to the power of negative 6 over 3 equals to x minus 4. At the end of it, we have to move the square root of 10 to the power of negative 6 over 3 to the right side and x to the left side. And then it will be equals to x equals to square root of 10 to the power of negative 6 over 3 plus 4. And it will be equals to 4. Therefore, the x-intercept is 4. Now, the second step will be to find the y-intercept. To find the y-intercept, we have to let x equals to 0. Now, y equals to 2 log bracket 3 bracket 0 minus 4 bracket positive 6. Now, because log 0 is undefined, so therefore there's no y-intercept. The third step will be to find the domain. Now, it's very simple because we have to use the inside, which is the 3 bracket x minus 4. And inside, it cannot be equals to 0. So therefore, x cannot be 4 because when 4 minus 4, it will be equal to 0. So therefore, x must be more than 4.
So now I'm going to continue from 6.4, which is power log of logarithms. Okay, so let's do some example. Okay, now we have to look for the x, so we know the x is the power, the exponent. The x is the exponent. So right now we have to solve this in order to get the x. So what do we have to do? So first of all, we have to put the base. So we know that the base is 4, we just write it 4, and then we kick it over, so 4x, power of x, and then the 64 we kick it over, so it is 64. So we need to know what multiply itself to become 64. So we have to practice, we have to use the calculator, or maybe we can just write it out. So it's gonna be like this. So 4 multiply 4, it's equal to 64. So we know that the answer is, the x is 3, the exponent is 3, so that's the final answer. Okay, so for now let's look at question B. So it's the same, so you just put equal, and then log 3, and then you see we have to simplify the 9 in order to get the smallest number. So we just log 3, and then we know that 3 multiply itself it's equal to 9, so we write it like 3, sorry, I shouldn't bracket, so you just write it 3, and then we know that the power is 2 because it multiplied itself, so we just put 4 aside. So log 3, as I said just now in 6.2, the base and if the base and the number beside is the same, we can just cut it. So the leftover is just 8. So the final answer is x is equals to 8. Okay, so now let's look at question C. It's the same. We put the equal. So log 2, we just follow the question, and then now we see like the 8, we know that 2 multiply itself like 3 times, it's equal to 8. So it's gonna be like log 2, and then we must make, actually, you know what, we have to make this number to equal to base, like we try to make it. So what we found is 2, and then we know is equals to the exponent is 3, so we write 3 5. Sorry, I should just remove the bracket. Okay, so as I said just now, if the base and the number beside it's the same, we can just cut it. So the final answer is 15. We know that the exponent is 15. Let's do a question about compound interest. So here's the question. So now we know like the equation is given, which is 2 equals to 1.05 time, and then we know that the doubling period, investment 5% interest, and also it's compound annually. So what we're gonna do is we have to, so don't forget it's still log chapter, so you have always remember to put log in front. So log 2, so whenever we put log in front, and whenever we put log in front, we have to put log at the back as well. So let me make this clear. So we just put like log 2, and then log 1.05. Okay, so we put it again. So like the exponent, if we don't know the exponent, we can actually kick it to the front, so it's gonna be like this, the exponent just now, log 1.05. So we kick it over to the opposite side, and then we replace it with the log 2, so it's gonna be t equals to log 2 divided by log 1.05. So that's the final answer. So yeah, thank you.
Now, I'm going to explain chapter 6.5, making connections, logarithmic scales in a physical sciences. Now, the pH scale is used to measure the acidity or alkalinity of a chemical solution. It is defined as pH equals to negative log bracket H plus, where H plus is the concentration of hydronium ions measured in moles per liter. Now, as you can see from the scale below, neutral is 7.0, and below 7.0 is all acidic until pH 1. The lesser it is, the more acidic it is. For an example, pH 2 is more acidic than pH 3. Now, above 7, it will be alkali. Now, the more alkali it is, it will incline outwards than 7, which is, I'm giving you an example. 14 will be more alkali than 12. Now, example 1 will be tomato juice has a hydronium ion concentration of approximately 0.0001 mole. What is its pH? First of all, we copy down the equation to solve this problem. And then we substitute 0.0001 inside the H plus, which is now, after that, we log it and we solve it. And we will get negative bracket negative 4, which is 4. Now, as you can see, the pH of tomato juice is 4. Now, we will go to example 2. Find the concentration of hydronium ions. Approximate pH of juice is 3. As you can see, the pH value of this juice is 3, which is below 7, which is extremely acidic. Now, to solve this problem, we have to use the formula again. Now, we have to use the equivalence law, which is we shift the base 10s to the left side and H plus will remain the same. And pH will move up to the power. As the question given, the pH value will be 3. So we sub in the value inside pH, which will give us 10 to the power of negative 3 equals to H plus. And therefore, H plus will be equals to 0.001. Now, I'm going to explain about decibel scale. Decibel scale is usually to calculate the sound level or the ratio of their sound intensities. Now, the difference in sound levels in decibels can be found using the equation B2 minus B1 equals to 10 log I2 over I1, where B2 is always the greater or louder one, where B1 is the lower and softer one. B2 and B1 is the difference B2 minus B1 is the difference in sound levels, and I2 over I1 is the ratio of their sound intensities, where I is measured in watts per square meter, which is W over M squared. Now we move on to example 1. How many times intense as a whisper if it equals to 30 to the sound of a normal conversation equals to 60? Now first we have to write the equation. Now as I said earlier, B2 will be always the greater one and B1 will be the always lower one. So it will be 60 minus 30 equals to 10 log I2 over I1. Now you will get 30 over 10 as you move the 10 over to the left side, and it will be equals to 10 log I2 over I1. So therefore it will be 3 equals to log I2 over I1. As you can see, we have to use the equivalence law again to solve this problem. So therefore, log base 10, move to the left side, it will be 10 to the power of 3 equals to I2 over I1. So therefore, the answer will be 1000. The ratio of these intensities is 1000. This means normal conversation sounds 1000 times as intense as a whisper. Now I'm going to explain about Richard scale. As you can see, Richard scale has the formula M equals to log I over I initial. Now M is the magnitude of an earthquake, and I is the intensity of the earthquake being measured, and I0 is the intensity of a standard. Now I'm going to move on to the example. How many times as intense as standard earthquake is an earthquake measuring 2.4 on a Richard scale? Now they give you the M, the magnitude 2.4, so we sub in the 2.4 in the M, which is 2.4 equals to log I over standard earthquake. Now we have to use the equivalence law again, which we move the log base 10 over to the left side, which will give you 10 to the power of 2.4 equals to I over I0. Now after solving it, we'll get the value of 251.9 equals to I over I0. Now the conclusion is this is 251 times as intense as a normal earthquake.